Hello friends. For years, astronomers have focused on the TRAPPIST-1 system as one of the best hope for finding Earth-like world with potential habitability. Initial evidence suggested that the TRAPPIST-1e, a rocky planet in the system's habitable zone, might possess an atmosphere rich in methane. Methane is the key biosignature of, indicator of potential life. But a groundbreaking new study suggests this signal may be a false positive. Let's explore this further. Hello, cosmic explorers, and welcome back to the channel. Today, we are diving deep into a story that has been making waves across the astronomical community. A story that challenges one of the most exciting discoveries in the search for extraterrestrial life. We are talking about TRAPPIST-1e, a planet often hailed as one of our best bet for an Earth-like world, possibly even harboring life. But what if everything we thought we knew about this atmosphere was a lie? What if its own star has been playing a trick on us all along? For years, the TRAPPIST-1 system has captured our imagination. Just 40 light years away, this incredible system orbiting a tiny, cool red dwarf star. Three of these planets, TRAPPIST-1, E, F, and G, reside squarely within we call the habitable zone. That's the perfect orbital distance where the temperature could allow for liquid water to exist on their surface. Out of these, TRAPPIST-1e in particular has always held a special promise. It has been envisioned as a temperate, rocky world, potentially blanketed by an atmosphere. And here's what it gets really exciting. Early observations through complex atmospheric modeling hinted at the possibility of a methane-rich atmosphere on TRAPPIST-1e. Now, why methane is so significant? Because on Earth, methane is a potent biosignature, often produced by living organisms. Finding it on an exoplanet like TRAPPIST-1e would be a monumental discovery, a potential smoking gun for alien life. Scientists have been eagerly using powerful tools like the Hubble Space Telescopes and soon the James Webb Space Telescopes to peer into the atmosphere of these distant worlds. We look for specific fingerprints in the starlight that passes through the planet's atmosphere at its transits or passes in front of it, of a red dwarf star. Each gas leaves a unique signature, allowing us to deduce what these faraway atmospheres are made of. But here is a twist. A groundbreaking new study published in the prestigious journal Nature Astronomy suggests that these tantalizing methane signals might not be from TRAPPIST-1e's atmosphere at all. Instead, it could be a masterful deception orchestrated by the very star it orbits, the ultra-cool dwarf star TRAPPIST-1 itself. This isn't just a minor adjustment to our models. It's a potential game changer that throws the habitability of TRAPPIST-1e into serious doubts. It forces us to reevaluate how we interpret atmospheric data from exoplanets, especially those orbiting these particular type of stars. Let's talk about the dwarf stars for a moment. TRAPPIST-1 is what we call an ultra-cool dwarf. These stars are much smaller and cooler than our sun. They are also incredibly long-lived, potentially burning for trillions of years. This longevity makes them attractive target in search of life, as it theoretically provides ample time for life to evolve. However, they are also known for being incredibly active, especially in their youth, blasting out powerful flares and radiation that could strip away planetary atmospheres. The problem lies in how we detect atmospheric gases when the planet transits its star. A tiny fraction of starlight passes through the planet's atmosphere. Different gases absorb different wavelengths of light, creating a unique spectral fingerprint. that telescopes can detect. This is called the transit spectroscopy. It's a brilliant technique, but it relies on assumptions that the star light is uniform and stable. But the ultra-cool dwarf like TRAPPIST-1 aren't uniform. They have complex surfaces with star spots, cooler, darker regions similar to sunspots, and brighter, hotter regions caused by stellar activity. These features can produce their own unique spectral signatures. The new simulation suggests that a combination of these stellar surface features, especially distribution of star spots, can mimic the spectral signature of methane in a planet's atmosphere. Imagine trying to determine what kind of glass a window is made of, but the light source illuminating it isn't steady lamp, but a flickering multicolored disco ball. It becomes incredibly difficult to isolate the properties of the window itself from the complexities of the light source. That's essentially the challenge researchers faced with TRAPPIST-1e. The disco ball of the TRAPPIST-1 star could be creating what's known as the false positive for methane. This study, led by researchers at the institute like the University of Maryland and MIT, utilized advanced 3D climate and atmospheric models to re-evaluate the data. They didn't even just look at the planet, to look at the star in an unprecedented detail, modeling its surface and its emission with incredible precision, and what they found was sobering. Their simulation demonstrated that a TRAPPIST-1e with no atmosphere at all but orbiting a star with specific pattern of star spots could produce the very same spectral signals previously attributed to methane. Let that sink in for a moment. We might have been celebrating the potential of an atmosphere that simply isn't there, tricked by the subtle complexities of its sun. So what does this mean for TRAPPIST-1e's habitability? If there is no atmosphere or a very thin one, the prospect for life diminishes significantly. An atmosphere is crucial for several reasons. It regulates the temperature, preventing extreme hot and cold swings. It can host liquid water for maintaining surface pressure, and it shields the surface from harmful radiation from the star. Without an atmosphere, TRAPPIST-1e would likely be a barren, airless rock, constantly bombarded by its star's radiation and incapable of supporting liquid water for long. This research isn't just about one planet, though. It highlights a fundamental challenge in exoplanet research, especially when dealing with red dwarf stars. These stars are the most common type in our galaxy, meaning the vast number of potentially habitable exoplanets orbit them. We can be fooled by TRAPPIST-1. What does that imply for other promising targets? That's a question. It means we need to be more rigorous, more sophisticated in our analysis. We need to account for stars in stars' own complexities, not just the planets. The new study isn't dead end for the search for life. It's a critical learning moment, forcing us to refine our techniques and develop even more robust methods for distinguishing genuine atmospheric signature from a stellar interference. This is where the James Webb Space Telescopes, or JWST, comes into play. JWST's incredible sensitivity and advanced instruments are designed to push the boundaries of exoplanet atmospheric characterization. While this new research presents a challenge, it also provides invaluable guidance for how JWST should be used. Future observations for TRAPPIST-1e with JWST will be crucial. They will need to be carefully planned to account for these stellar effects, perhaps observing the star directly at a different time to build a comprehensive map of its surface activity. The scientific process is all about questioning, refining, and sometimes overturning previous assumptions. This is not a failure, it's a progress. It's a science work exactly as it should. The doubt cast upon TRAPPIST-1e's atmosphere doesn't diminish the excitement of exoplanet planet exploration, it makes it more complex, more intriguing, and ultimately more accurate. So while the TRAPPIST-1E may have lost of its initial luster as a prime candidate for life, TRAPPIST-1 system as a whole remains incredibly fascinating. There are still other planets in its habitable zone, and the lessons learned from TRAPPIST-1E would undoubtedly inform our studies of future studies of them. So this journey to find life beyond Earth is filled with twists and turns, with moments of triumph and moments of profound recalculations. The universe is complex, and deciphering its secret requires immense patience, ingenuity, and willingness to challenge even our most cherished hypotheses. TRAPPIST-1E atmosphere mystery serves as a powerful reminder that the universe doesn't always reveal its truth easily. Sometimes even the light from a distant star can be a trickster, testing our resolve and pushing the boundaries of our scientific understanding. So, friends, what are your thoughts on this new development? Do you think TRAPPIST-1E still holds promise, or we back to square one? Let me know in the comments below. If you enjoyed this deep dive, please hit that like button, subscribe our channel for more cosmic adventures, ring the notification bell so you don't miss our next video. Until next time, keep looking up.